Hello all, let's start section 4.3. Our section 4.3 is properties of logarithms. Of course, in section 4.2, I covered few basic rules of logarithms for you that if you want to see it again, I will list them here. Then we go to the main three properties of logarithms. In 4.2, we covered these rules. Rule number 1. If I have log of 1 base b, my answer is always 0. Correct? Rule number 2. If I have log of b base b, my answer is always what? 1. Rule number 3. If I have log of b to the power of x base b, my answer is always x. And rule number 4 that we learned, b to the power of log x base b, my answer is always what? Always x, not b. Correct? These were the 4 basic rules of logarithms that you learned in section 4.2, and we did some very simple examples, a few of them in section 4.2. Now I'll start section 4.3 with the first important rule, which we call it the product rule. What the product rule actually says to you, or you should learn it as a rule number 5. If I have log of m times n base b, a product between two positive numbers, I can rewrite this expression as a log of m base b plus log of n base b. At the same time, we call the right side of this expression expanded form, and the left side we call it the condensed form. Correct? Condensing form. Expanding form, condensing form. And remember, if they give you one single logarithm and they ask you to write an expanded form, you go this way. If they give you an expanded form and they ask you to write it as a one single logarithm, you go backward this way. That's why I put an arrow with two sides on the top. Rule number 6. Rule number 6 is your quotient rule, correct? Quotient rule. It's basically the same as product, but the sign will be negative. If you have log of m over n base b, you can rewrite in an expanded form as a log of m base b minus log of n base b. Rule number 7, power rule. If you have log of a number m to the power of p base b, what you do, p comes to the front of logarithm, then you can write as a p log of m base b. These 7 rules of the logarithms, if you memorize them, if you understand it, you can deal with any logarithmic problems and you can solve any of them, correct? I'll do a lot of examples today for you. I will start with a very simple forms of examples. Then we go to the complicated form. Complicated means in complicated forms of the problems, we combine 2-3 rules together to work. But in simple form, of course, only one rule. Example number 1, expand. Or they're asking you, write this logarithmic expression in expanded form, or in simple language, just expand. Correct? Log of 7 times 5 base 4. To expand this, I'll see it's a product rule. Then I can write log of, you see actually 7 is your M, 5 is your N, and 4 is your B. And you have your formula that log of M times N base B equals log of M base B plus log of N base B. Then I'll just apply the rule. I can write log of 7 base 4 plus log of 5 base 4, my final answer. B. Log of 10x. The other day when I talked about the types of logarithm, I told you that we have logarithms that we call it common log and the base is 10, and we have natural log which the base is e. If you don't see in a logarithmic expression that there is no base, immediately you should know that your base is what? Your base is 10. That's a common log. Correct? I put here 10 in a red color, but in an actual example, they don't show this base. No one writes base 10. Correct? When there is no base, it means it's base 10. But in this example, I put the 10 as a red color here for you to explain the example for you, correct? But in future, if you don't see a base, immediately your base is what? 10. Now, again, product rule, I can write this one as a log of 10 plus log of what? Log of x. And I told you your base is actually what? 10. Now look at here. Log 10 base 10. You had a formula that log of b base b always gives you 1. Then this part, log of 10 base 10 becomes 1 plus what? Log of x. Example number 2. Again, expand. Log of x over 2, of course, base 10, or log of x over 2. Quotient rule, right? Then I can write log of x minus log of what? Log of 2. Very easy. Next one. Log of 19 over x base 7. Again, quotient rule. The log of numerator, which is log of 19, base 7 minus log of denominator, which is log of x base 7, done. One more. Interesting one. Not always log. Let's do this time ln. ln of e to the power of 3 over 7. Again, apply the quotient rule. It will be ln of e to the power of 3 minus ln 7. But look at the first part of the problem. The first part of the problem is the power rule. I just explained to you that if you have log of m to the power of p base b, when you write it in expanded form, you bring this exponent to the front of log. It means you write p log of m base b. It means here, if you want to apply that rule, this one will be 3 ln e minus ln 7. And if you remember, I told you the other day, ln of e is always what? 1, correct? Then you can write this one as a 3 times 1 minus ln 7, which gives you 3 minus ln 7, final answer, correct? Example number 3. All of them, we write them in an expand form, or I just write here expand. Log of or ln, what I'm writing, ln of radical x. Remember one thing, every time that you are dealing with the logarithmic expression or problem, if you have a term that's radical is involved, change the radical to exponential form. You may ask me what does it mean. It's a topic from intermediate algebra, it's a topic from bigger algebra, but still I will read right here for you. If you have the n root of a to the power of m, correct? You can write always this one as an exponential form. You can write a to the power of m over what? N, correct? Remember this from algebra, beginner algebra or intermediate algebra? Then here, what I do, I'll change for a square root of x in exponential form. That's my first step. I'll rewrite my problem as a ln of x. Here you see your index is 1, your index is 2 and power of x is 1. Then I can write here ln of x to the power of 1/2. Now power rule, bring the exponent to the front. You can write as a 1/2 ln x, final answer, correct? Some more complicated ones. Let's go to a kind of bigger problems. Example number 4, expand. Log of x squared square root of y base b. We want to expand this. Again, I have product rule, but before applying product rule, I see here a square root. I will first rewrite this one in exponential form. Then I will write log of x squared y to the power of 1/2 base b. Now I will apply the product rule. I can write log of x squared base b plus log of y to the power of 1/2 base b. When you expand, you have to do it all the way. Here you see you have again exponents in the top. Now I'll apply the power rule and bring the exponent to the front, correct? Like this. It comes to the front here, to the front of log. Then I will write 2 log of x base b plus 1/2 log of y base b. That will be writing your logarithm expression in expanded form, correct? Example number 5. Log of cube root of x over 36y to the power of 4 base 6. First, you see the cube root, you have to write it in exponential form. Rewrite the problem. Log of cube root of x means x to the power of 1/3 over 36 y to the power of 4 base 6. Now apply the quotient rule. Then log of x to the power of 1/3 base 6 minus log of 36 y to the power of 4 base 6. But here you see 36y to the power of 4. It's again a product rule. You can simplify it as addition, right? Here you can bring the exponent to the front. You can apply the power rule. Then you can rewrite this one as a 1/3 log of x base 6 minus, here, change the product to addition rule, log of 36 base 6 plus log of y to the power of 4 base 6. Now we have to simplify more, right? Then 1/3 log of x base 6, distribute the negative, minus log of, you see 36, because my base is 6, I'm trying to write, if it's possible, 36 as a base of 6, 6 to the power of something. 36 means 6 squared, right? Then instead of 36, I will write 6 squared base 6. And distribute the negative also here, minus log of y to the power of 4 base 6. Now, again, bring the exponents to the front of log and simplify. Then 1/3 log of x base 6 minus 2 log of 6 base 6 minus 4 log of y base 6. One more step, right? I'm a good student. I can see all the rules. Log of 6 base 6. Log of 6 base 6 is giving me always 1. Then my final answer will be 1/3 log of x base 6 minus 2 minus 4 log of y base 6. Correct? In these examples, we change one single logarithm to expanded form. Now, in the few next examples, I'll change an expanded form to a one single logarithm or in condensing form, correct? Example number, I don't know, 6, 7, how many we did? We did. Example number 6. Write as a single logarithm. Write as a single logarithm. What is the problem? The problem is log of, again, we will start with the simple ones. Log of 2 base 4 plus log of 32 base 4. When you write an expanded form to one single logarithm, you see I zoomed out a little bit my page. Actually, you are doing the steps from the bottom to the top. The problem isn't given in expanded form. You have to go all the way up to write as a one single logarithm. It means The exponent rule that you did at the last, here it comes as in the first step. If you have a number in front of log, first you have to move the number to the exponent. Then apply the rules. It's actually you are going from the bottom to the up, correct? Now, look at here. I have addition. Addition, I can change it to product as a one single logarithm, right? Then I will write one log, I'll open a parenthesis, 2 times 32, and one of the bases, which is 4, which gives me log of 64 base 4. But can I write 64 as a base of 4? Definitely yes. I will write log of 4 to the power of 3 base 4, which gives me 3. If you see rule number, for example, 2, I don't want to apply here the power rule again. If you have log of b base b to the power of x, your answer is x, right? That means here your answer is what? 3. Another example. Let me do more. I don't know which example. 7? 8? Example number 7. Let me write 7. I don't know which one. 1/2 log x plus 4 log of x minus 1. Write as a one single, I forgot here to put 1/2 log x. 1/2 1/2 log x. To write as a one single logarithm, if you see a number in front of the log, first move this number to the exponent, right? You see I have 2 of them. I'll move them to the exponent. Then I will write log of x to the power of 4 plus log of x, not x to the power of 4, x to the power of 1/2. I'm excited, I do a mistake. Okay, log of x minus 1 to the power of 4. Now addition, to write addition as a one single log, you have to change it to product. Then you can write log of x to the power of 1/2 times x minus 1 to the power of 4, all base 10, whatever the base is. I think base is 10. Correct? Here, x to the power of 1/2, you can write it in radical form. You can write as a log of square root of x times x minus 1 to the power of 4 as a one single logarithm. Correct? There are different examples in this lecture. When you do your homework, when you do practice, just follow the rules that I explained for you. Believe me, chapter 4, which we are dealing with logarithms, the easiest chapter in your book, correct? Because we just followed the rules. One more rule that I want to put here for you, and then I'll stop the lecture. We call this rule the change of base. The change of base property or rule. If you have log of a number m base b, to calculate this log, you can write this one as a log of m base b over log of b base a, sorry, log of b base a. I didn't discuss too much with you on 4.2. logarithm, if you use a calculator, to find a logarithm of a number, correct? Let me open a calculator for you. This is my calculator. And if I change it to scientific calculator, here is the button log. If you want to find the log of a number, your calculator always calculates, gives you base 10. Your calculator is programmed to confine the base of logarithms of the numbers if the base is 10. If your base is 6, 7, 2, or any other number, your calculator cannot find that logarithm. And you should remember that uh, only and only positive numbers, they have logarithm, because when you saw the graph of a logarithmic function, which I did, I think only one example, you see the domain of your logarithmic function is always positive numbers, correct? In this case, you can say that, hey, the logarithm of a number is always what? Is always positive. Now, the change of base, I will not focus too much on this. We will not do examples, but I just explain to you, because in this class, I'm not with you inside the class to show you how to actually use the change of base formula. That's why I try to skip this section. Not section, this part of the lecture, but just I put it as a formula for you. Remember that there is a formula by name change of base, correct? I'll stop the lecture here and see you all next time in section 4.4, which we will discuss exponential and logarithmic equations. They are really, really interesting. I will discuss it with you in section 4.4.